I'm Dimitri, and we're going to talk to you today about truth tables. First of all, we're going to be discussing what is a truth table. Then we're going to be discussing what it's used for, the notations and symbols used to connect statements. We're going to be going through basic and more advanced examples, and then we're going to be relating those examples to social, environmental, and ethical implications. First of all, what is a truth table? Basically, it's a diagram of columns and rows that breaks down the logical functions into all possible occurrences to solve the question. Now we're going to talk to you about why we use truth tables. Basically, it's used to visualize the statement in a practical form. It also breaks down the question into columns and rows to gradually solve the question with the answer at the end. It helps analyze the argument or statement, and it's easy to understand for the person doing the question. It's used to determine the outcome and to test if the argument is valid or not.
Hi, I'm Brenda, and here are some notations and symbols for a logical statement. So P and Q are just our two statements, and here are the symbols to go with it. So first one, we've got and it's only true when both are true, or it's only false when both are false. Implies it's false when P is true and Q is false. Not and, it's false when both are true. Not or is true when both are false. Exclusive or is only true when P or Q is true. Otherwise, if it's both true, then it's false. Or when it's both false, then it's false. And not, it means the inverse of P and Q, which is our statement up here. So it's not P and not Q. And for logical equivalent, it means two statements have the same result. So a quick tip onto how to remember how to distinguish them two is simple. So and is like an A, which is like that. So it goes up. And also for not and, it's an up arrow, same as this one. And for a not or is a down arrow, which is the same as this one.
Hi, I'm Sathyan, and so this is an example of a truth table. And in every truth table, you have to find the possible combinations between both statements, which are the P statement and the Q statement, to work out all the rules identified. So this symbol, as previously mentioned by Brenda, is the AND symbol. So for the rule P and Q, it is only true when P is true and Q is true, and it is false otherwise. With the next one, which is OR, it is only false when both P is false and Q is false, and therefore it makes all the other statements true. Coming to the last one, which is P implies Q. It is only false if P is true and Q is false, therefore making it true for all the other statements.
Hi, I'm Vera, and continuing on from before, a tautology is a proposition that is always true. So here we have an example. So we have the example here. And the two statements are P and Q, so it's always true, true, false, false, and true, false, true, false. And P implies Q is true, false, true, true. So now continuing on, we have P and P implies Q, which is these two. So we have, so if it's and, it's only true if both are true. So the first one will be true. The second one, there's a false, so it will be false. The third one and fourth one are also false, so it will also be false here. And finishing the example, we have P and P implies Q and implies Q. Is only false when P is true and Q is false. This is Q and that's P, so the first one will be true. Unfortunately, they're both false, so that's also true. And yeah, it just becomes true, which is a tautology.
Hi, I'm Andrew, and I'm going to talk to you about three types of implications. We have the social implication, which is if I finish my homework, then I will go to the party. This shows, through this statement we can see that P is if I finish my homework and Q is I will go to the party. This is obviously a P implies Q statement due to the terminology used with the word then. Within the environmental example, we can see that the statement says the plant will die unless you water it. As we can see, P is obviously do not water it, and not P is water it, which is the opposite of P. And Q also being the plant will die. As we can see also from this terminology, the word unless, this shows that P does imply Q. On the third and final implication being ethical, if you do follow the law, you will not get arrested. Then you will not get arrested. This shows that P is if you follow the law, and Q being you will not get arrested. With the word again, then being there, the terminology shows us that it is a P implies Q statement. Therefore, all three being a P implies Q statement, which is always false if P is true and Q is false.
As you can see, truth tables might seem very complex, but after understanding what it is used for, what they actually are, the statements and symbols that are used to connect statements, practicing basic and more advanced statements into truth tables, it's easy to understand why we use them and their importance for solving questions.